good. I only bought 3 hats in Dublin, so
Oh,
I have a slight addiction to hats, I would say.
No, no. Now we can wait a few more minutes.
So technically, there's something wrong on your slide. 9:30 UTC and 9:30 GMT aren't exactly
Yeah, are the same.
because there's like
Are the same.
not exactly because
Are the
leap
same in
seconds
this time.
leap seconds are handled slightly differently in
Ah.
GMT and UTC. GMT, like it spreads the leap second out, whereas UTC has a set function.
Yeah,
So
yeah,
you could be off by
yeah.
400 or 500 milliseconds. Maybe. Just say it. Just say it. Yeah, indeed.
Yeah, yeah, yeah.
has anybody, any of you followed the IETF conference with the money parallel?
No.
No.
Because they just discovered, one of my colleagues there, they just discovered there's a new TPP in data centers now. Previously, NTP was supposed to be sufficient, but now with all of the AI synchronization across different nodes, nanosecond precision is required.
For a while back, I got really big into timing for a while, and so I had a 3 cesium box in my basement at a company.
Okay.
GPS laying ones as well.
And don't you need some sort of nuclear permission for this?
But you do need all sorts of regulation if you're shipping them.
Yeah, you're right.
Because they contain cesium, and like the amount of like paperwork to ship them.
I know we went through this once, and then we thought, no, we don't want to ship.
Yeah.
Because we have always this event in France where we present the results, and we figured like, oh, putting this little box on the truck is a no. You can't do that. And it's dual use as well.
Okay.
No, dual use.
Okay, sorry.
I think we can start. Come on. Yeah, we just wait 5 minutes. Sarah, I don't think that will join because she told me that she has a flight to take at the same time. Anyway, welcome to Benchmarking Working Group in Dublin, IETF 121. I'm one of the co-chair, Giuseppe. If you are not subscribed to the mailing list, please do. Okay. We are at the IETF. This is a reminder of the IETF policies because we are working here under the code of conduct of the IETF. So by participating in the IETF, you are agreed to follow the IETF policies, processes, If you are aware of some IETF contribution that is covered by any IPR, please um, uh, consider to look at the IETF rules. As a participant, you agree to work respectively with other participants, and please contact the Ombuds team if you have questions or concerns. There are also denote really well. So all the meetings, virtual, on-site, mailing lists are intended for professional collaboration and networking. The ITF aims to create and maintain an environment in which people of many different backgrounds and identities are treated with the same dignity and respect. And you can always contact the ombud person in case you have some concerns or if you want to notice and if you want to raise your concern. Anyway, the meeting tips, okay, for in person, make sure to sign in into the session through the data taker or the QR code. If you are on site, you can use the on-site tool to join the my queue. Please do that and participate in case of shows or events. For remote, you can use the remote tool and make sure that your audio and video are off unless you are presenting, of course. We also need the note taker, any volunteer. We can have also more than one. Okay, thank you, Paolo. But the note tool is a collaborative tool. You can join the note if you want to integrate and extend. Let's go to the agenda. We have the slides that I'm just presenting, 5 minutes. After, we will have the presentation from Masiak about the multiple loss ratio search. Then Vladimir will present the Young Data Model for network tester management. Then Min Gong about the considerations for benchmarking network performance in container infrastructures. Then Paolo with benchmarking methodology for segment routing. These four presentations are related to working group drafts, adopted draft. Regarding the new proposals, we have Gabor about the recommendations for using multiple IP addresses in benchmarking tests. Then Shuesong for the SRv6 service benchmarking. Li Bin Liu about the benchmarking methodologies for source address validation. Luis about the calibration of measured time values between network elements, and then Romain about the benchmarking methodology for power in network devices. Any bashing needed? Any other business? Okay. Yeah. If not, let's quickly go through the current status of the working group. There are two documents, let's say, preparing for the working group last call, the multiple loss ratio search and the Young Data Model for network tester management. Another document has been recently adopted regarding the benchmarking for segment routing. Proposals got some discussion on the mailing list. So the recommendation for using multiple IP addresses in benchmarking tests, the SRv6 service benchmarking, and the benchmarking for source address validation. And new proposals are also coming, in particular the benchmarking for power and energy network devices and the calibration of measured time values between network elements. Of course, you are welcome to reviews. You know how we work in IETF, so your work is adopted, completed, but you also need to contribute and review the work of the other contributors. Uh, so we have a draft in the RFC editor queue. The benchmarking methodology for stateful NATIC SIPs gateways using RFC 4814 pseudoram port numbers. We aims to start the working group last call. I already discussed with Sarah regarding the multiple loss ratio search. We have some candidates for working group adoption, but maybe we will further discuss later. We also need to update the milestone about the multiple loss ratio research. Anyway, we can start with the first presentation. I think this is the last slide. Okay, this is just about the milestone to be updated. Let's go with Mashek. Please start.
Hi, Giuseppe. Hi, everyone. Welcome to our presentation of the update to the MLR search version 08. Radko and me will be presenting. Next slide, please. So we have posted an update on the earlier end of October. The main changes from 07, there are minor changes in the spec section, but we have a bit more of a rewrite or major update in further explanation section. I will cover the main changes. And then we also added more examples of the runs of the MLR search, especially in comparison to addressing the full compliance with RFC 2544 and TST 009, as Giuseppe kindly pointed out. I think we would like to go into the workgroup last call after this meeting. Next slide. So this is really the agenda for a quick presentation. I will focus on the deltas from 07, but I will also recap the main problems that we are addressing with this proposal. Next slide. So this is recapping the 5 problems that the spec is going after. Long search duration, reducing the search duration is critical, especially for when the benchmarking and throughput measurements and discoveries are part of the automated CI/CD pipelines for software networking. So that was the actual original goal behind this work, and then it evolved from there. The DUT and SUT. The main focus is really on environments where RFC 2544 and TST 009 do not address fully. So specifically software networking workloads, applications that use shared resources, where finding a single performance number is hard, and hard to have it in a repeatable and comparable format across multiple environments. So instead of focusing on single performance number, we are after a spectrum and or a range of performance, and especially focusing on finding the noiseless part. And then addressing 2 other aspects: finding the performance with non-zero loss frame, which is a common practice these days, and dealing with the inconsistency of trial results due to the fact that we're searching for multiple goals and different loss ratios. Next slide. So those 5 problems, or at least 4 of them, have been, we discussed this with a work group, got feedback, and I think they got validated. So that's what we're going after. So this covers the new subsections added. There are some auxiliary terms to really focus on easing the explanations. Current final quantities. So current quantities are the ones that are tracked within each phase of the search or step of the search. And there are some examples at the bottom, upper bound and lower bound. Unlike in binary search, they are actually current quantities, and they are then translated to something referred to as relevant upper bound to lower bound to actually track the search per goal, or sorry, the results of the search per goal. We classify trials from their sort of loss rates, so the high loss level, so high loss, low loss, and also from their duration level, short, full length, and long. Next slide. So this is the section that actually has undergone a major update, and that is really to explain some of the new things that came in MLR search. The stopping conditions, which haven't been really spelled out in RFC 2544, they clearly specified here, and also the relations between the loss ratios, loss inversion, and how the searching for multiple goals may result in classifying the same load as upper bound or lower bound depending on the goal, and also the approach that MLR search takes when things like that happen, going with a conservative, so the worst case, assuming basically a worst case scenario. Next slide. And the final set of subsections in the further explanation focuses on explaining exit ratio and how it is used to filter the results and trying to get us closer to the noiseless end of the spectrum. There are some recommendations about selection of trial duration and the impact of short trials, and the case made for why we need a generalized idea of the throughput, and specifically explaining the conditional throughput that is defined in MLR search. And Radko will actually cover one of the examples illustrating the conditional throughput calculations. Next slide. And with that, I would like to hand over to Radko.
All right. Hello, everyone. For this presentation, I have prepared two examples. In the draft version 08, we have more fleshed out ones, so you can see more details here, but this is just a quick illustration of how those examples look like. Each example showcases one part of MLR search logic and uses only one search goal and presents a particular situation during the search by listing available trial results so that you can see how those results are affecting the decisions that MLR search prescribes. So for this first example, I have chosen the RFC 2544 unconditional compliant search goal that we flesh out in the draft. So it is unconditional compliance, so the final trial duration has to be 60 seconds. Only one trial is needed per load, so goal duration sum is 60 seconds. No frame loss is tolerated during the trial, so goal loss ratio is 0%, and the new value of exceed ratio, it is maybe not obvious why we have chosen 0%, but I hope in this example it will be visible. So the situation during the search is quite minimal. We have only one trial measured so far. It has been measured at a load of 1 million frames per second. The trial duration was only 1 second, so presumably there were some other optional inputs to this particular algorithm so that it shows this short trial duration, and the measured trial loss ratio was 0.5%, so not 0. According to these new auxiliary terms, it means this trial is short and high loss. Next slide, please. So here is the complete description of the load classification that describes the logic fully. Of course, in this simple example, most of the operations do not really change the results too much. So let me skip most of them and highlight only few numbers, few lines. First of all, line 3, this is short high loss sum. This is where our one trial result appears, and it basically goes through without any changes to the line 8, which is effective high loss sum, and that is important because it appears as a numerator in line 13, that is optimistic exceed ratio. So basically we have 1 second of a lossy trial, and we have time for 60 seconds, and that means we already have 1.6% of exceed ratio. But in this case, the goal exceed ratio was exactly 0, and this means even after one trial, we already have the exceed ratio that is larger. That means we can stop measuring this load because this load has become an upper bound. So this is an example of quite extreme time savings using MLR search and short trials, but this also shows why we choose those strict values like zero exit ratio for this goal. It enables this time savings, and when even one trial has ended with a non-zero loss, it is unlikely full-length trial will have zero loss. So I believe in this case the decision is a good one. And I think that's everything I wanted to tell about this slide. So next slide, please. So in this second example, we will be showing the computation of the conditional throughput, and I have chosen the other search goal we have in the draft that is based on the TST009 document, and in this case it allows call duration sum to be 120 seconds. That means 2 full-length trials are expected, and the goal exit ratio is 50%. That's the spirit of this document to allow some full length and high loss trials if they are compensated with a large enough number of low loss trials. For the situation during the search, we are at the end of the search. There may be other trials at different load values, but for this particular conditional throughput calculation, only the trial results executed at one load are important. So this load is once again 1 million frames per second, and we have 2 trials. Both of them are full length, so 60-second duration. But first of those trials that got measured is high loss, 0.9%, and the second one is low loss, 0%. After the first trial, it was still not sure what the classification will be, but after the second trial, it is clear that this value is a lower bound. So next slide, please. And here is once again the complete logic as described in the draft. Here I can highlight the line 3, which is 120 because we have 2 trials, and this is simply sum of those durations. And line 5 applies 50%, so we start with buffer containing 60 seconds. And I think I can jump to line 8, which applies one trial, but important thing, those trials are applied sorted, so the zero loss one goes first, even if it was measured second. And the remaining sum is decreased by the duration, and 60 minus 60 is 0. So after this first loop, we are already at 0 remaining sum. That means that in the line 9, the second trial is not applied. That is the logic. And as only the trial with 0 loss got applied, its forwarding ratio is 100%. So when we multiply that by the load, we still get the same value of 1 million frames per second, and this is the conditional throughput in this example. More interesting examples involve non-zero goal loss ratio, but you have to look at the draft for them. This basically shows that when we have an exit ratio of 50%, so we would expect some value to be a median, but we have exactly 2 trials, so median is not well defined, and it is in this case not the usual average, it is the better case. So that shows another big part of the requirements that are in our draft. And do we have some time? Okay, let me go very quickly through the next slide. I don't have time to go through the details, but this is another piece of discussion that were not present in version 07, and it talks about how the trial results are expect it to depend on trial duration. There are 4 possibilities. The 2 middle ones are common and they are fine, but the first one and the last one highlight the sensitivity of the trial duration, and for the first one it works fine, it just prolongs the search, but for the last one there is a possibility that you will get too low results because short trials can cause classification as an upper bound, as we have seen in example 1. And yeah, I would like to know whether other groups and their SUTs, whether they see the behavior of the first kind or of the last kind, because if those are frequent, we will need to think deeply about what trial durations are correct to use. But if the middle ones are frequent, then we do not need to care about it as much, and things are good. Yeah, I think that's everything I can afford to talk about it. So yeah, Maciek, please continue.
Thank you, Radko. Giuseppe, please, next slide, please. Yeah, so in terms of work status, the draft is ready for the last call, and we would appreciate a thorough review by the working group, and would like to march towards the basically finishing the work. Next slide, please. So references. We are using MLR search in the Linux Foundation networking. I'm saying we, it is used there. Radko and me are part of the project. Linux Foundation networking, fast data IO. MLR search is used to test software networking workloads like VPP, DPDK, DPDK sample applications, L2 forwarder and L3 forwarder. And it's also used for TRX back-to-back calibration. The current settings, and we're running those jobs and the tests at the level of a few thousands a day. The goals that are set and used, MLR search settings used for in FDIO, we have something that we refer to as zero frame loss or non-drop rate search goal, and the values are listed on the slide. The loss ratio there is 0%, so this is really a zero frame loss. But the goal duration sum is 21 seconds versus RFC 2544 60 seconds, so it's a bit shorter. The second goal is PDR, partial drop rate, and that's where we accept 0.5% loss ratio. And we're using the MLR search to benchmark the software versions themselves. It's part of the CI/CD pipeline, so changes to the data plane software are measured. We also verifying and measuring the performance of this VPP DPDK workloads across different server systems come out of the shelves. So in the FDIO lab, thanks to LFN, we have a privilege to have a range of Xeon servers, including the latest Sapphire Rapids, and the MLR Rapids just arriving. And we have ARM servers, latest from NVIDIA Grace. So this is the Neoverse V2. And we also onboarding a Marvel DPU. We also have DPUs. We have AMD servers and a few others. So bottom line is, we're basically gauging the software performance across different platforms, and MLR search is pretty much underpinning everything that we do. And one maybe of observation, as I have another minute, is that MLR search allows us to execute many more tests than binary search would be able to execute, allow us to execute in terms of the frequency of tests due to much shorter duration. So we have quite a big efficiency gains there. But we're also able to find this zero frame loss throughput, which apart from RFC 2544, there's no other methodology to do that in a standard way. today, and it's an excellent alternative to a method that developers are using, which is basically pumping at link rate and verifying what comes out on the other end. What we notice that quite often systems suffer from overload and basically yielding wrong results. So we believe that this, with MLR Search, we're providing developers with an excellent benchmarking tool to gauge their code performance and efficiency improvements. And with that, next slide, please. I would like to thank you and open the floor to any questions. And sorry, I couldn't help promoting maybe a bit on what we're doing in FDAO. Hopefully you don't mind. But MLR Search really is a critical part of the work we're doing there. Thank you.
Thank you, Maciek, Bratko, for the presentation. Any comments, input, suggestions?
So thank you for the. Can you hear me? Can you hear me?
Close to the mic.
Okay. So thank you for adding these auxiliary terms. I think they help a lot to understand how the algorithm works and volunteering to review the draft. Please give me 2 months because of any other obligations.
Okay, we are supposed to start the working group last call in the coming week, so maybe if you are able to review before, but let's see.
Okay, thank you.
Gabor, thanks very much. Yeah, we're looking forward to your feedback and reviews.
Any other comments? Okay. Thank you, Maciek, Bratko. We will be back after the meeting, so for the working group last call.
Thanks very much, Giuseppe. Thank you, team. Thank you.
Vladimir?
Hello.
Hello, Vladimir.
Hi. Hello.
Do you want to the control of the slide? Or?
Is it just the arrows left and right? That's what I need. Yes.
Yeah. Otherwise, you can just say next slide.
Yeah. If it works, I'll just press the buttons. If it doesn't, I'll ask you.
Let me. I have passed you the control, so you may be able to.
Yes. So this presentation is short, just summarizing the what we did during the hackathon. So the module changes that are done in the 0.5 version of the draft add a container that has information about the WAST sequence error during a test on the analyzer module. So it is part of the configuration of the analyzer, and then if there is a sequence error, it records the WAST event with the timestamp of the moment of reception and the expected sequence number and the received sequence number, which is useful for a number of tests. Like RFC 2544 has 2 test cases: system recovery, which needs to find out when sequence errors or dropped packets stop after traffic overload with 110%. And the other test that is an example of why this functionality is needed in implementation requirement for test case is the reset, where you power cycle a device and then you wait until the max throughput is restored to no sequence errors. So having the WAST sequence error recorded is what you need in many of those type of tests. So we added this to the model, and The hackathon plan was simple, just start the same tests that we used before and add something that exercises this new functionality and implement it. So validate the modules, that was simple, that was done before committing them and submitting the draft version. And during the hackathon, we ran some simple tests simulating. We have not got to the target testing because it's still synthesizing the latest changes which we have. So to test that, we improved a bit the test bench. So we have the Python RFC 2544 talking to a netconf server implementing the model. And then what we used during the hackathon was simulation of the Verilog at like a limited speed, like to be able to do it in a matter of seconds or minutes. You need to go down to like 10 kilobit per second interface, and you simulate about 30 seconds, 30 frames. And that's good enough to see that the counters are properly operating. So we added this device under test instance, which is a very simple packet filter that drops packets if they come with a shorter interframe gap. And this is like the simplest type of interconnect device that you can test, and knowing what it should report the test is what we use to validate. So this is how this Python benchmark running against a simulated point-to-point connection using this implementation of the draft. It's like the shortest RFC report for a single frame size. This is 64 bytes. For this frame size, this is what the RFC test should report. The only thing that is not compliant is that the period is shorter, and the latency measurement is done only with one run because it is so deterministic that it really doesn't need more than that. So then you see, in order to simulate the packet drop, we reduced the minimum interframe gap with 1 octet. So instead of doing 12 plus 8, which is 20, you can see this simulation changes to 21. So then packets coming in a burst, one is discarded every second one. So then we pretty much knew what the results are expected to be. And this is the binary search trying from 20 octets interframe gap, which is 29 frames, goes down to half of that, and then goes up to, in the end, it figures out that it's 21 octets interframe gap that the point-to-point connection allows as a maximum, and it's still 29 packets per second with that speed. So this is what we expected to see exactly, and this is what the test provided. So then to actually validate, so with that we acquire like all the signals, all the complete walk reported by netconf, so we could actually check out of that walk file that is generated here. We can see all the netconf transactions, so that we can get and present in this presentation a datagram with netconf XML, which configures the traffic generator, and then we just for showing, we have taken another excerpt showing the reading of the status containing this last sequence error. So as you expect in the second trail, trying to figure the bandwidth, you lose approximately every second frame. So you have plenty of those instances where you can read last sequence error, where the expected sequence number is the expected +1, what is received. and then you get the timestamp. So this was operating correctly, and we can see all the other values that we have implemented so far. So this is good. And then to get down to really analyzing, we had to put some test cases for the firmware and gateway implementation, which we use this file that is generated conveniently by the simulation, that during this less than 1,000 frames, you have every single signal in the logic, very well described logic, that you can actually go and check. And here you can see how actually the registers that record this thing presented in the model actually get incremented, so that you can, if you suspect something, you can go and look into that log. So this is like something that we will publish on GitHub as a branch to the main repository, so one can actually see what we actually run and analyze that alongside with the netconf simulation and RFC 2544 complete log of the netconf session that was doing this RFC 2544. So this like very good reference design, I think. So this is about it for this presentation. It's technical details, and all the links for the implementation and the repositories are behind this slide, which I'm not going to go through. They have been presented. We just have them for reference because these repositories get updated every time we commit and work on the project. So this is about it. I think this functionality is good and necessary for many tests. We are to complete the RFC tests on target, but we didn't manage to do it during the hackathon session. So this is coming in the next days. Yeah. So if there are any questions, interest, we're very interested in reviewers and people who would like to get some hands-on experience. So we are trying to go to like FPGA conferences, validation conferences, and get some interest from companies that would like to use Young and NetConf in pre-silicon simulation. I think this is a very powerful tool. So yeah, any questions? I'm done with the presentation.
Thank you, Vladimir. Yeah, any questions? I have one question, as let's say, as a participant. You are, I think it's a valuable work, because we need to define the Young model for network generator, for analyzer, and you are following the RFC 2544. I'm just wondering. So my question is, of course, is the model flexible to accommodate the next updates to this RFC, for example, the MLR search, or the possibility to use multiple IP addresses? So, did you check the flexibility for future extensions?
I have been following the latest work on updating the RFC, and like for example the search algorithm. I think Vratko looked into like adding an implementation using this interface that we use. So he committed some changes to the script. And we should probably like complete this by running a test. It should be no problem to do that, because you just have this simple Python script where you can run the trails of required by RFC 2544. And it seems like we didn't find any like problem to do that. We just haven't tried to make any runs. it should be possible, and we can look into it. But other things like more flexibility to the multiple IP addresses and things like that. The only thing that the model has is the option to like be augmented with external YAML modules if there is more use case specific functionality that is needed. Like it has the ability to specify like incremental changes to certain fields of the packet, but there is no protocol context. So it is the way this is standardized. We're going for the simplest use cases. And if someone wants protocol specific context, something that doesn't just increment fields and does something more specific, is free to write extension augmentation YAML modules. So this is the main concern, to like allow for this kind of dynamic packet modifications, probably required by more advanced tests that are complex, to be done by people who actually have overview of that and the competence to do that. But what we are aiming for is what is widely used, which is RFC 2544, and a couple of other standardized tests. So if we manage to make a model which is very simple, that would be a very useful thing. So that's what the goal is, at least.
Yeah, it makes sense to me, because just this will be one publish as RFC will be a reference, and people that are willing or are proposing new tests can just extend or augment this YAML model. And I also have one second question. Since you introduce these new parameters, are you willing to add more parameters in the next versions, or do you believe the draft is becoming stable?
I think the draft is becoming stable. I also think it needs users and reviewers, but mostly users, because those are the best reviewers. So that should be like the goal. Like we need a lot of people using it and providing feedback, and there is no need to speed the work with publishing it. So I think it is realistic to say that we can allow it one more year before we put a deadline or end date, because it's useful changes, useful experience, and I'm working on getting more people to start using that. So if someone helps me with that task and tries it out, that would be great. That can make it faster. Like if someone moves to using this for something useful right now, the way it is, that would be a very good step to maturing the work and claiming that it's ready for publication.
Okay. We have Ratko in the queue. Please go ahead.
Yes, so as a participant and a possible user, I have a few comments. My first comment is that this looks like a useful, let's call it front end for traffic generators and traffic analyzers. And I believe it is possible to pair this front end with different backends, like existing traffic generators. For example, in CSID we are using T-Rex, so it will be fine to have some integration code that can pair this front end with T-Rex as a backend, and it will just work. Of course, this integration software is not straightforward. So somebody has to take time and implement it and test it, but I see it as a possible future, mainly because in the multiple occasions there are definitions that are talking about specific test stream. In ML search we are calling it traffic profile, and having one unified front end will also help to define these traffic profiles in a way that is independent from specific backend details. So useful work, but still someone has to do it. That's all from me.
Yes. Yeah, I totally agree.
Okay.
That's we have support for one commercial tester, which is not one of the most popular ones, but it's quite good. We have used Unritsu, and we have been able to validate the results. Like it is providing an RFC 2544 reports, and we have compared this with the ones used from our Python script with the backend as connecting to Unritsu, interpreting the configuration to its Skippy configuration interface. And we think this can be done for other network testers as well. And T-Rex is a good option as well. The only problem with T-Rex is it's not that deterministic. Like it is more focused on software defined network systems, virtual network infrastructure and things like that. So it is not that deterministic, but it is not a problem to implement it with the provision that it will not be that deterministic. It will still provide useful results in most cases. Yes, I'm done.
Thank you, Vladimir. Yeah, because we are running a little bit late. So, but we can continue the discussion on the list. And thank you, Vratko, for the inputs.
All right.
Mingong.
Okay, can you hear me?
Yeah.
Okay, hello everyone. So this is my presentation about the update of the document consideration for benchmarking network performance in containerized infrastructures. We go next slide.
Yeah.
So a quick reintroduction about the scope of the draft again. So this draft scope is to fill in the gaps of the previous benchmarking document IFC about virtual network function benchmarking IFC 8172 and 8204. So this document proposes to provide additional consideration for benchmarking VNF when applying into the container infrastructure. Please go next slide. So from the previous meeting, we have contacted the IFC 8204 authors, and we received review and comments from her. So there's an update. We have already received her approval to make modification into our documents. So the first one is that we modify the figures of acceleration networking model to show the hybrid continuous networking stack inside the system. So for acceleration networking model, we have two networking interface for at least two networking interface for XCNF. One will be a default network interface created by the default CNI used for port management and control plane traffic, and at least one is used for accelerated CNI. And this is used for accelerated user application traffic, which is also the benchmark target. And this is enabled by the Mantis CNI. We go to the next slide. And this hybrid continuous networking stack is applied for all accelerated networking model. So we have group all of the accelerated model, the user space, EPF, SmartNIC, and model combination into one section. And the kernel networking model is renamed to normal non-acceleration networking model. So for the non-acceleration one, they only one single CNI for both IPAM and user application traffic. But for acceleration networking model, we have to use multiple CNI and one default CNI for IPAM and the other one for acceleration traffic. You go next slide. Then the second update is that in the normal non-acceleration networking model, is a kernel networking model, we modified the CNF figure to show that inside the CNF we have their own Linux networking stack. It is separated from the hot networking stack because this is a feature of the CNF of the container infrastructure, and it's only applied for this non-acceleration networking model because in accelerated networking model, data path is optimally configured to reach the user's application via accelerated technology library. We go next slide. And the third update is that we changing the word of choice to correctly describe the EPF and AF XDP technology. So for the EPF, instead of using enforce policy, we are changing to EPF e-trigger to process packet, where it arrives as a traffic control hook. And for the AF XDP, instead of using tunnel by password, we change it to AF XDP enables an in-kernel short path. We go next slide. Then we add Sensden to mention about the container network acceleration via XPU networking device in the SmartNIC acceleration model section. Because this is a new technology nowadays, and XPU is actually there are any processing unit. There can be a DPU, there can be IPU, and the networking device they can contain the SmartNIC itself and other CPU core and their own acceleration engines. XPUs are new acceleration technology option and has not been widely implemented and documented yet. So as recommended by Mariam, the IFC authors, then we only add the information into the wrap, add then some additional information for future consideration. Please go to the next slide. And for resource configuration consideration, we have a new section that is for AF-SDP configuration, because AF-SDP can operate in busy and non-busy polling mode. And in the non-busy mode, different CPU core can be allocated for either application or packet processing. So the CPU core allocation in non-busy mode can be an resource configuration need to be considered when benchmarking container network when using AF-SDP. We go to the next slide. And about other comments from her, we have reached an agreement with her that we will not change inside the draft about the first thing is the EPF AF-XDP data network part. Actually, EPF at the XDP hook can not only it can forward packet to the AF-XDP socket, but it also can forward packet to your normal networking stack or drop the packet or revert it back to the original interface. But this is not accelerated data path, so we do not add it inside the document. And about the receive size scaling configuration at the NIC, this one is not unique in the container infrastructure, so it's not mentioned inside this document. You go to the next slide. So that's all the update that we have addressed from Mariam comments, and this is a short review of the review history that our document had received. So before adoption, we received a review from Viper project from our previous BMWG chair directly, and in late 2023, we received a review from BMWG members at the meeting. And after the adoption, we addressed the comment in the WG adoption. And for this one, we already addressed the comment from the related IFC 8204 document. If you go to the next slide. So that's it. We address the IFC outer IFC outer commands and all chain word update and to the new version of the document. So we think the document is in the good shape now, and it's possible to request the last call now. Thank you.
Thank you. Any comments about this draft? Any inputs? I want to thank you for the detailed explanation of the exchange and the latest updates after the comments from Mariam. I also read the exchange on the mailing list that it was, I think, it is a good progress for this draft. So yeah, thank you. And regarding the working group plus call, we will discuss offline. Anyway, if there are any comments or otherwise we will move to the next. Thank you.
Thank you.
Paolo.
Okay. Hope you can hear me. Yeah.
Just a moment. Yeah, you can start.
Yeah. Okay. So quick update on our work since the last ATF. So you see I'm presenting as usual on behalf of the other co-authors. Next slide, please. Okay. Scope of the draft. Well, we have discussed it quite a lot during the previous ATF. I guess it's probably something we started 2 years ago. So should be clear right now. It's basically to define the benchmarking methodology to measure the performance of a segment routing capable device, the forwarding performance. So in doing that, we extend the work introduced by the RFCs you see listed here in the slide. Status of the draft, you remember it was adopted by our working group after Brisbane, so IETF 119. And we discussed and presented at the last ATF, introducing the main changes that we did so far. The main one, you remember, we dealt with the integration of the two original drafts, one taking care of the benchmarking of SR-MPLS and the second one, benchmarking of SRv6. There was a long discussion. We decided to integrate the two documents, and basically what we presented at both the IETF 119 and 120 is the result of that integration. And thanks clearly to anyone who provided support, feedback, comments, and new ideas. Okay. Again, very quickly, the story of the draft since its adoption. Version 00 was uploaded in June, and we presented 01 at the last IETF, highlighting the, let's say, the remaining comments that you see listed here. So basically, we had the request to change something about the fragmentation, especially for SRv6, which clearly is not allowed. Some clarifications on how to deal with SRv6 on a destination node, other editorial changes. And this version, which we uploaded, I guess, the past month in October, addressed probably one of the most important remaining comments, which was about the introduction of the compressed seats for SRv6 clearly. So where we stand right now, you remember we discussed the possibility to share the draft with other two working groups, Spring and SRv6 Ops, and thanks to the chair that helped us to send the draft to them, and we are waiting for their comments. I guess probably this is one of the very last steps that we just need to address before asking for the last call. There is one remaining comment, which is, let's say, still open, even if the authors, the co-authors, believe it's not that relevant for the draft, which is about security. There is one ongoing draft dedicated to security in, let's say, in segment routing, specifically segment routing version 6. But we are dealing with performance testing in a closed environment, which is the lab. So we believe there is no serious impact. But honestly, we wait for your feedback if you think the same or not, if you have different opinions. The other point that we'd like to, again, share with you, we'd like to introduce in the draft something about the real usage of our methodology. And we need to be clear here. Sometimes in the past, we asked if you have any public results of the test using the methodology defined in the draft. Actually, we are not looking for the specific results. For example, in lab X, we have tested vendor Z, and the results are the one we are providing the draft. No, it's not the case. We are not going to compare the vendor devices. We just need just look for, let's say, something that says, okay, the tests are good. We can measure the performance of a device. They are effective. They are in scope of what we have put at the beginning of the draft. So I would say those are the remaining steps we just need to address before asking the last call to the chairs. For sure, we are going to wait for the result of the cross post. So I guess it takes probably one more cycle. I guess maybe we will wait until the next IETF. After that, we presume to be ready for the working group last call. So let's say it could be a matter of a few months more. And I think that's it. Thank you.
Okay. Any comments, inputs, reviews? Please.
I recommend you to include one short sentence in the security considerations that this is a laboratory test and this is why it is not relevant. Okay. That's it. Thank
Okay.
you.
Okay.
Okay.
Thank you. For sure.
Any other comments? Yeah, through the app you should.
Okay, so Carsten from ENTC. Yeah, I'm happy to review the document. I'm really sorry I didn't get that done before this meeting. We have some draft comments internally, but I didn't get to finalize that. And of course, I'll also try to use it in public tests so that we can report something.
Thank you,
Thank you,
Carsten.
Carsten. This is very important.
Yeah, if there are no other comments, thank you, Paolo.
Okay, we can save
yeah.
3 minutes.
Yeah. And now we can move to Gabor to the new proposals. Let's see. You can use this.
So I'm Gabor Lenche, and the outline of my presentation is the progress of the draft and a few slides as a reminder about what this topic is, and then my new measurement results about how many IP addresses should be used. So let's begin. This is the outline of the progress of the draft. So 1 year ago, I presented this as a new idea in Prague, and it was the problem statement. And the next IETF meeting, I presented some measurement results to prove the effectiveness of the solution. And now there's one issue is remaining. It is about how many IP addresses should be used. And I did some tests regarding this, and now I will present these results. So just as a few signs as a reminder about the program description. So you will know RFC 2544. It has defined the test frame format with fixed IP addresses and fixed port numbers. And there was an update, RFC 4814, introduced pseudo-random port numbers, but it kept the fixed IP addresses. And it is the problem because we now use receive side scaling to be able to receive multi-million packets per second by modern CPUs that have multiple CPU cores. And this RSS receive side scaling has two kind of implementations. The first type includes only the IP addresses in the hash function, and the second type includes both IP addresses and port numbers into the hash function. And if you use this RFC 4814 pseudonym port numbers with the second type of RSS implementation, that's great because the port numbers give the entropy and everything works fine. However, if we use the pseudonym port numbers with the first type of RSS implementation, that doesn't work because even we have pseudonym port numbers, but we only include the IP address in the hash function, and it means that only 2 CPU cores will work, 2 because of the bidirectional traffic, 1 in each direction, but the test will be results will be very poor. However, if you use the same device to forward internet traffic, it will perform satisfactorily because the internet traffic contains multiple IP addresses. So it means that the conditions of the laboratory test should be improved. And the idea is very simple. Similar to IRC 4814 that recommended pseudonym port numbers, we should use pseudonym IP addresses. Now we should solve 2 problems. The first problem is what IP address ranges can be used. The ranges are much limited for IP version 4. They are much more abundant for version 6. And the real question is what ranges should be used, because I will show a trade-off. Okay, let me change the slide. Oops. Okay, so this is a drawing when the test and device and the test are connected and they're in the same network. Of course, for the IP version 6, the last 16 bits can be used, but a few IP addresses cannot be used because of one is assigned to a tester and the broadcast and the network itself, so -3. So 64K -3. And this is what I did with the test, that first I assigned 1 IP address on each side, and then I doubled their number with 2, 4, 8, and so on. And of course, these are the combinations are the products of the 2 values, and the hash values are the double because of the 2 directions. So it was the test system, use the tester and the device under test, and they were first in the same network, and 2 interesting issues here. I decreased the CPU clock frequency to make the bottleneck the computing power, and I used the first type of RSS implementation when only the IP addresses were the part of the hash function. So these are the results. It was not a surprise that first there was a low result, and when I doubled the number of IP addresses, the results became much higher and higher, and then reached the performance plateau. And on the right side of the figure, you can see some serious degradation because the high number of IP addresses, you see it's from 8K times 8K, the ARP tables were overloaded, and the likely second level cache of the CPU was exhausted, and the results dropped. Of course, here you could say that anything from, let's say, 100 to 8,000 is good, but this is just a particular case. So other devices may have much more CPU cores, and they may have much lower second level cache. So the figures can look differently for different other devices. Yeah, here you can see it's a similar but a bit different for IP version 6. Sorry, it was version 4, and this one is version 6. The title is not good, but it's version 6. And so the problem is the optimal number of IP addresses. And the problem is that there's a lower and a higher limit, so we should eliminate at least one of them. And this is the idea that we put not in the same network the test and the device under test, but virtually there's a gateway to which the device under test forwards the packets, and the test case is not in the same network. And of course, the gateway's IP address is mapped to the MAC address of the tester, so it will receive the packets. This for IP version 4, and the next one is IP version 6, very, very similar. And in this case, the benefit is that we use only one IP version 4, IP version 6 mapping to MAC address per sides, so altogether in 2. That is, the ARP or NDP tables are not overloaded, and we have the opportunity to use all the potential IP version 4, version 6 addresses, because no entry is necessary per IP address. So this is the results. So the blue ones are the same. The first type of RSS implementation, when only the IP addresses took part in the hash function, and the other color shows the case when IP addresses and port numbers took part in the hash function, and the results are virtually the same. So it means that even in the case when the first type is used and the second case type is used, the result doesn't change. So the recommendation is now complete, that first of all, we are able to support the first type of RSS implementation by using a gateway and by using all the available IP addresses. So we believe that our method is now stable and usable in practice, and it significantly improves the conditions of laboratory tests by removing their bias agents, the first type of RSS implementation. So we have the usual questions. If you think this thing is usable and appropriate, and of course, what do you think of working group adoption? Thank you for listening.
Thank you, Gabor. Comments, suggestions? Anyone is willing to review this comment, to give some feedback to Gabor? We will push more on the list. Anyway, I will surely have a look. And I didn't read the last version. I have read the previous version, and I think, of course, the work is useful. And anyway, let's wait for more feedback on this.
Okay,
thank you. Next presenter. Yeah.
Hi, this is Xue Song, and I will give some update about our work, SRv6 service benchmarking guideline. These two slides are the same the same as our previous presentations. Just give some information about what we are trying to do. The motivation is that we have some observation that in benchmarking working group, a lot of work is around single device benchmarking, beginning from RFC 2544. And from the experience of on-net testing and some other test work with service provider, we think network level benchmarking is also very crucial. And the difference is that the single device benchmarking, the topology will be like the tester and the device under test. And also for the network level benchmarking, there should be ingress, egress, and also the transit node, and to make it a whole network and connect it to the tester. We also think this kind of work will be also very crucial in benchmarking working group. So we take SRv6 as an example, just like the previous work that has already been introduced. There has already been a working group document about segment routing benchmark. That is for that has already included the SRv6 behavior in data plan for a single device, and a series of behaviors have already been included. For example, the encapsulation, the flavor, and also other different data plan work. So based on the single device benchmarking, we are trying to propose the benchmarking of SRv6 service. It means like we want to provide some guidance to the users if they want to test the different types of service, whether it can be transported through SRv6 network. So that is the contents in our existing version that we try to cover two classes of service. The first one is in SRv6 best effort service, and another one is SRv6 traffic engineering service with compression or without compression. And there are three types of services, including internet service, layer 3 service, and Ethernet service. So what is the progress? Actually, after the presentation in IETF 120, we have collected some feedback in working group. It has mentioned that there is no test topology in our document. So in the updated version, we have and the test topology, which is composed of two devices and also the tester. And also, there are comments from chairs. There is a new working group called SRv6 Ops, maybe also interested in this work. So we send off a document to the SRv6 Ops mailing list to collect feedback. And we have received some comments from the mailing list. They are coming from three aspects. Sorry, the text is a little small to read. Basically, there are three comments. The first one is that the topology we have introduced kind of simple, because in the real test, there will be multiple devices, especially including the protection scenario. But now we only have two devices as SRv6 network. Our response is that because this is just the first try of introducing a service level benchmarking, so we want to make it the most simple way and make the test repeatable. And the second comment is about the SRv6 OEM benchmarking part, and it is mentioned that there is some mistake about the description, and we have already updated in our existing version. And the third one is about the result report. The comments mentioned that it may be too simple to just describe that the service is be transported successfully without packet loss. There is no characteristics that is critical in benchmarking test. So we also would like to contribute more in this aspect in the following version. And we also add a new co-author, Gao Wei, who has rich experience in SRv6 test. And here is our consideration for the last comments we have received. Because in RFC 2544, they have already defined some very well-known benchmarking tests. We pick three very typical ones: the throughput, the latency, and the frame loss rate. For each benchmarking test, there is the objective, the procedure, and the report format. And we think we have reviewed the whole benchmarking test, and we think the process of RFC 2544 maybe can directly reused for the service level benchmarking, especially the throughput and the frame loss rate. But for the latency, considering the timestamp is used, so we think maybe the type synchronization should be considered, and that will make it a little difference from the previous one. So in our following version, we will end the benchmarking test part for our document and to give some guidance about how to reuse the existing work in RFC 2544, and also how to add some new characteristics for service level benchmarking. And also we are looking for other experts from benchmarking to give more guidance. Especially, it is mentioned by chairs that there is some work about RFC 2544 bis. So we think maybe we can also collect suggestions from them to seek their suggestion for this kind of work.
Thank you, Shuesong. Any comments? Please.
So I understand that instead of you testing just a single device, you want to test an entire network. My question is, if you put this network into the laboratory, or is it a live network?
It's actually it's in laboratory, in lab, because
lab,
we
yeah.
only have 3 devices: the ingress, the egress, and the P node. So the benchmarking test can be really simple because it's just the import of the ingress and output from the of the egress.
Yeah, it was my concern because throughput test may not be used in real life networks.
Yes,
Yeah.
yes,
Okay.
it's in
That's
lab.
correct.
Yeah,
Good.
yeah.
Thank you.
Thank you, Gabaria.
Yeah, maybe we can give some explanation for that part in our document. It's for lab.
Thank you. Any other comment? Yeah, if not, we will move the discussion to the list. We continue on the list. Yeah.
Okay. And another comment, maybe we in our document there are some also some contents about the maybe related to the our existing segment routing benchmarking document.
Okay.
Maybe we can contribute. To
Of course, of
yeah,
course,
to
of
the
course.
existing document.
Yeah,
And
yeah.
we
You can talk with Paolo. Yeah.
Yeah, yeah, yeah. Sure.
And Paolo, just for since you are taking the notes, if you look at the chat, Boris mentioned that he will review the draft from Gabor, and if you can just write on the notes about that, so we can keep track. Okay. Yeah. Yeah. Okay. Go ahead.
Good morning. I'm Libin Liu from Zhongguanzhen Lab. Today, I will present the updates of the benchmarking methodology for source address validation. So this document will define the methodologies for benchmarking the performance of source address validation mechanisms. It is going to take the approach of considering a cell device to be a black box and define the methodology in a manner that is agnostic to the mechanisms. And it's going to provide a method for measuring the performance of existing and new cell implementations on the devices. In total, we have updated 3 versions from IETF 1.2.0. Today, I will present the version 0.2. Okay, before introducing the main updates, let me repeat the motivation for this draft. As we know, proposing a standard benchmarking methodology is important for evaluating the performance of intra-domain and inter-domain sound mechanism fairly. For network operators, the benchmarking methodology can help them to get a more accurate idea about the performance of their cell devices in their deployed network environments, and in order to utilize and help them to select the appropriate sound mechanisms in their network. And for device vendors, the benchmarking methodology can help them test the performance of the sound implementations supported by their devices. Also, as you know that in sound network group, the benchmarking methodology can guide how to evaluate whether the proposed new intra-domain and inter-domain mechanisms satisfy the design requirements defined in the intra-domain and the inter-domain problem statement draft. Okay, here is a summary of the comments on this draft after we present it in IETF 1.2.0. Most of them from Aijun Wang and Su. We summarize them here. The first type of comments is about the definition of sub-performance indicator. In section 4, the protocol speaking agent processing throughput is suggested to be simplified as protocol message processing throughput. And then in section 5.1, within the test cases 1 and 2, the direction of the traffic is suggested to be swapped, and the description of them should be based on the DOT's view. And in section 5.1, for the test scenarios or performance convergence performance measurement, we are suggested to discuss a method for the prefix withdrawn within the IGP proactively, and discuss how the DOT records the beginning and the completion of the protocol convergence. Okay. In the further DSR scenarios in figure 11, sorry, we are suggested to give a method to control the return traffic to take the path from S1 to take the path including the DOT. And we also suggested to change the locations of the DOT in the topology for testing the interdomain style mechanisms. Okay, and we also Adrian also suggests that we shorten the number depths of the subsections in section 5, and Sue also suggests us to consider the protocol convergence time measurement by referring to the existing routing protocols. Okay, here are our responses and the revision summary. In section 4, we have revised the protocol speaking agent processing throughput to protocol message processing throughput as suggested. In section 5.1, we have revised all related figures and descriptions to clarify the directions of the traffic for describing symmetric and asymmetric routing scenarios for testing intra-domain sound mechanisms. And in section 5.1.2, we have discussed the operation recommendations for withdrawing prefixes proportionally and measuring the protocol convergence time on the devices. And in section 5.2, we have revised the descriptions of figure 11 and added the requirements about controlling the return traffic from tester to the user along the path including DOT. In section 5.2.1, we have discussed more test cases to test the accuracy of DOT by changing the locations of DOT in the network topology. Also, we have optimized the structure of section 5, and we have updated the descriptions of protocol convergence time measurement by referring existing routing protocols. Okay, for the detailed updates of the test cases, for clarifying the traffic directions in intra-domain cell, in total, we have revised all these 6 figures and descriptions of the traffic for constructing symmetric and asymmetric routing scenarios for testing intra-domain cell. Okay, for the detailed updates of protocol convergence time measurement, first, the protocol convergence time is calculated by subtracting the beginning time from the completion time of the protocol convergence process. In the draft, we discussed that withdrawing prefixes proportionally for IGP can be achieved by shutting down the interfaces proportionally in the estimated topology. For example, as shown in the figure, the tester connects to an emulated network topology with each interface connecting to an emulated device. So the tester can connect, for example, the tester can connect to 10 emulated devices via 10 interfaces. And the 10 emulated devices can advertise their prefixes to the DOT via the tester. So in this scenario, to withdraw 10% prefixes, the tester can shut down when interfaced to the emulated device randomly. Okay. For the detailed updates of the test cases in DSR scenarios for testing interdomain cell, the figure here will show a scenario of cell for customer facing AS in the DSR scenario. So S1, S2, S3, the DOT, and the S file constructs the test network environment of DSR scenarios. And here the DOT performs some as IS. And the user can access the any custody destination along the path S2, DOT, and S3. So to direct the return traffic from the edge server to the user along the path that including the DOT, it is recommended to configure a static route to direct the traffic with source addresses in P3 and destination addresses in P2 to the DOT. Also, the locations of the DOT can be changed to S1 and S2 to evaluate their cell accuracy. For other test scenarios, it is also applied. Okay, for the next step, we seek feedback and comments to promote this draft in our group. Also, we are going to implement a benchmarking tool based on SAL-OP, which is a SAL open playground and which is also open sourced on GitHub. And also collaborations are welcome. Thank you.
Thank you. Any question, comments? I have two questions. Okay. The first one, are you preparing the tool and are you planning to do some hackathon or something like that?
Yeah.
For the next IETF?
Yeah. Because before maybe before next meeting, we will implement a benchmarking tool and we will present at the hackathon.
Okay, for the next IETF.
Yeah.
Okay, that's good. And one more, did you also present this work in subnet working group or not?
Yeah, because Subnet is working on some mechanism, right? So we also present it at Subnet. But
okay, no, it's good. It's good. And did you receive some feedback in subnet working group?
Yeah.
Since some okay.
Thank you. But mainly we want to promote this draft in BMW.
Yeah, it makes sense. But since the experts are in subnet, I'm wondering if you presented it in subnet, someone review, someone is interested.
Yeah.
Okay. Yeah. And if you can ask these people to join BMWG and post their comments on the mailing list.
Okay, thank you.
Thank you. Luis? No. Just one moment. Okay.
Hello, everyone. This is Luis Contreras from Telefónica. I'm bringing here a new idea, a new proposition for calibrating the time values that are measured between the routers when running T1 or stamp test among them. So let me go through that. So yeah, the time clearly, well, here is very well known here, but basically the time stub in packets can be used for calculating the measured delay in a path between an origin and a destination. The idea is to compose the measurements hop by hop. The routers nowadays are able to run this kind of tests, so we can test T1 or stamp or different delay measurements between routers, so that we can get at the end, by collecting these individual values hop by hop, we can collect the end-to-end delay in a given path. The usage of this is relevant in other works here in IETF, for instance, for flex algorithms, in order to determine what would be the low latency topology. Also for services sensitive to latency. So this is more related with deterministic networks and so calculations in the PCE, path computation element for the bounded metrics or the metric in a path and so on and so far. Also network slicing could be related to this for the SLOs in order to accomplish the specificities of a given slice in that respect. So the aim of the document is to propose a methodology for calibrating the values. I will comment right now that what we are observing in different implementations, I mean, different vendor solutions, is that the time reference in these hop-by-hop calculations is not always the same. So the idea here would be essentially to determine what is the bias and use that bias in order to correct the calculations that we could do in whatever control plane element so that we have a very good reference that is not deviated from the real value on those calculations. And here, basically, we are proposing this common measurement scenario for that. So the common measurement scenario, because as I said, the different implementations have provide different values on the same conditions. So the idea would be to determine a baseline calculation that would be done with through a tester. The idea would be from a tester connecting two ports of the tester with a fiber spool of a given length, known length, so that we can determine what could be, let's say, the reference value. We can know that there are some estimations of 5 microseconds per kilometer. So with that measurement, we could have, let's say, the baseline. Against we will compare the values from the routers against that baseline. So two different scenarios could be considered. The single network element test, but basically we are testing from one card to another card in the network element and understanding what is the values that are generated in this case with the different cards, or I mean, if the T1 or if the timestamp is resolved in the line card or in the processor and so we can test in this variety of conditions for just one single network element, or also there would be the second scenario between network elements, and these network elements could be from the same vendor or from different vendor. Okay. So for these two cases, the idea would be to check the obtained value in the network element or between network elements against the reference value that is the one obtained with the tester. So what the document proposes is to define the measurement conditions. So identify the network device model, the hardware that is being used, the software that is being used for the network element specifically. Also to specify the length of the fiber spool so that we can have this reference, and this reference is common for whatever network element that we will test. Description of the ports or line cards where the fiber pool is connected. As said, different implementations of the different cards in case that the timestamp is performed in the line card could have different values, could be solved in the timestamp could be solved in different ways because it could be done in the ASIC, in the network processor, or even by software in some cases. Also, the protocol used in the measurement. If we are using T1 Lite, we are using a stamp or whatever protocol that we were using. Also, to define the duration of the test in order to have a statistical consistency. So repeat and reproduce the test in the same conditions independently of the network element that we are testing. And finally, the network tester used for generating the baseline values, so that that there is reproducibility. We can reproduce, let's say, the test, or I mean, whoever can run through this spec, if finally is adopted, could reproduce the same baseline values. So in version 0.0, we have identified already some issues to tackle, and the intention is to be covered in version 0.1. One of the issues is to assess differences between distinct line cards and on-port behaviors. This is something that we have validated in the lab. Sorry, so different line cards for the same vendor producing different values. So the idea would be, let's say, to tick this as a point to consider as well. Then evaluate if there could be scalability aspects here. We are measuring hop by hop connections. In that connection, there will be basically one flow for testing. We can maybe consider different flows for different classes of service, but we also, in the case that the time stamping is somehow done by the processor, probably there could be an influence of scalability if we are running the test from different ports. So maybe this is something that we need to consider if it is interesting to have or not. Also load aspects, if this means that if in the port that we are testing, we have other background traffic that could influence on how the measurement. Then important as well, the fourth point, the resolution of the chain measurement. So how far we go in the resolution. I mean, if we take microseconds, nanoseconds, milliseconds, so this could be relevant later on for the usage of these measurements. So what is the value that could be reasonable? And probably here we need to look at what is expected in the flex algo algorithms or in the PCE or whatever, so to determine what could be the proper resolution for this test, so that the bias and the obtained value somehow are consistent with the expectation of the consumers of this bias, basically, of this calibration. The fifth point, the possibility of considering asymmetric scenarios. So there could be situations where there are the different path length in upstream and downstream, or fiber length in upstream and downstream. So maybe it could be something to document as well. And the last point is about it makes sense or not to extend this approach to other network elements. I added here switches, but the T1 and STAM is for IP devices. So not sure if it could make sense to consider other network elements, maybe microwave nodes that I mean whatever node that is having IP addresses there. So maybe could make sense to test. As next steps, or idea, apart from presenting here and socialize the draft, the point here would be to collect feedback from you to understand if there is interest on this work here in BMWG, and then complete the draft with the open points already identified and whatever other that could come from the discussion today or in the mailing list. And for sure, we will prepare a new version for next IETF. Thank you.
Thank you, Luis, for presenting. Shuesong?
Hi, Luce. I think this is very useful work, considering in my presentation, I mentioned that what we are trying to do is to measurement the multiple devices. Actually, I think I also have seen in your slides, it's not for one single device, it's for the path. So do you think maybe because this kind of provide um, to provide a measurement method for different types of latency, right? So do you think there should be some reference relationship, for example, from our work, if we want to provide benchmarking test for latency, we can just refer to this kind of work?
I think so, especially for the traffic engineering case. So I presume that in segment routing traffic engineering, one of the services to, or the situation and scenarios to test would be the one of low latency. So maybe leveraging on flex algo algorithms, the flex algo algorithm for low latency, basically. So here the point would be to ensure that the flex algo topology includes the proper value, so not disturbed by the bias. So if we want, let's say, call it a calibrated reference for the measurement, I think could be some relationship among them, especially for the traffic engineering cases. So for the BSF4, you don't take decisions based on latency, but for traffic engineering, you could have decisions based on latency. So in that situation, could make sense.
Actually, I kind of understand that when we do traffic engineering, we are, there is a requirement of latency measurement to see whether it has satisfied our latency requirement. And but my consideration is that this kind of work can also be used for best effort, right? Although the latency maybe not cared so much, but it still works.
I don't see the value for best effort in the sense that probably for the best effort, you don't care if there are if the exact value of the latency reported is correct or not. More or less, you are in some orders of magnitude, but you don't have the actual need of a precise value for latency.
Okay.
So maybe I think that the value for best effort is diluted. I try to think that this is more valuable for when you require very precise low latency paths, so that you can discriminate topologies or nodes based on that measurement.
Okay, I think I understand the work better. It is for precise latency measurement. So if we have the requirement of precise latency measurement, especially for traffic engineering, it can be connected.
Yes.
Yeah. Okay.
Thank you. Let's be quick with the questions because we have another presentation. I just have one quick question. Did you mention, as a IPPM contributor, did you mention that you are testing this with STAMP and T1 Lite? Are you planning also to do the same for hybrid methods. I don't know, IOM or alternate marking.
Could we are not doing that now in the
Okay.
lab, but I think could be doable.
Yeah,
or
maybe
could be something to be considered.
Yeah, for the draft, it can be considered. So it can cover all the IPPM methods.
Yeah, whatever mechanism that we
Yeah,
use.
yeah,
Because
Okay.
the point here is to calibrate, not
Yeah,
to.
But the calibration can be also different based on the methods in general.
Yeah, could be because depending on how the router solves the
Yeah,
timestamp could be different. Yeah.
Paolo, yeah.
Thank you for the presentation. Just a quick question. Take into consideration, I haven't read the draft yet, so maybe my question is out of scope. But just for my curiosity, you are baselining the latency using a tester. Are you considering also to use other methods such as, I don't know, precision time protocol, something which is generated by the network and compare it against that?
I was not considering that, so it's something maybe we can discuss and see it makes sense.
Yeah, Carsten Rosenhüttel, thanks for the presentation. I would have a follow-up question to Paolo. So first, I think PTP is a good means and does not. Yeah, so that would be one question, one point maybe. But the bigger question is, how precise is the measurement with a fiber spool? Obviously, it depends on the type of physical layer. So whether you use multi-mode or single mode, the latency in the fiber will be different. And also, if you use technology like 100 gig Ethernet, which has multiple channels, of course, it's arbitrary. So in one measurement, you can have one result, in another measurement, you can have another result, depending on which channels are being used. So that's one point. The other point is for IPPM. I think it would be good to have a method to calibrate the whole algorithm and not only with one very specific set of, because it's time consuming to exchange the fiber spools, and typically you have them in like buckets of 1 or 5 or 10 kilometers or something, so you can maybe add them, but you cannot have a fast test and an arbitrary test of different lengths. So for this kind of reason, we at ENTC we use impairment emulators, which you can program. And also the impairment emulators have the advantage that you can not only calibrate the whole algorithm, not only one specific data point, but you can also calibrate how it reacts to delay variation and how it reacts to other flex algo conditions like loss, for example. So I think if we would have a calibration draft or calibration RFC generically how to measure these kind of network situations, then it would be useful, but only for calibrating fixed length cables, I'm not so sure how much value it would add.
Yeah. Regarding the last point, the value here is basically because these will be the values being consumed by other protocols to feed the control elements. So it's basically that the purpose here is to be sure that the control elements can the best decision that they can take. And basically this is the point. So it's not so much going into the calibration of the hardware, let's say, of the network element, in the sense of just understanding if the network element is good or bad. It's not that the initial purpose. The initial purpose will be that the value that is reported by the network element can be corrected so that the control plane can take the best decision for the setting up a path, and you know what I mean. That is,
I understand the theory, but I mean already 2 years ago we ran flex algo tests with much more advanced methods using impairment generators. So I'm not sure if we're really up to the state of the art here.
The impairment generator could be something to be added. No. But probably other aspects that you were mentioning, the packet loss and so on. Maybe we can assume that the packet loss, well, it's something that maybe can be considered. I'm not sure about that. Regarding the fiber spool network impairment element, yeah, maybe something that we can consider. Thank you.
Yeah, I would suggest to continue on the list because we have the last present.
Thank you.
Thank you, Luis. Romain.
Yep. Can you hear me fine?
Yeah, you should also have the control.
Yeah, I do. Yes. Thanks a lot.
Clint Eastwood. Go ahead.
Yeah. All right. All right, it looks like the layout of the slide is a bit messed up, but I hope that will be fine. So hello everyone, I know I'm standing between you and lunch, so I'll try to be brief. I'm here today to talk about, I've been invited to talk about this draft, but I will not really talk about this draft. So why am I giving this talk? Essentially, I've been researching the ways to reduce energy usage in wired networks for about 2 years. And when I started doing this, what seemed to be clear is that we have some ideas of what could be done, but we have a pretty loosey understanding of how much we could expect to save. And consequently, nothing really happened because, well, operators don't really know whether any of those ideas are worth implementing. And so what I've been doing in this past 2 years, I've been to try to come up with power models that would then enable us to derive or estimate how much we could save by those power saving measures. And essentially the process is what led me into this benchmarking draft. So as you can see here on the left, the process is pretty classic. We have a dot that we connect on the one hand to a power meter that will monitor the power being delivered to the device under test, a router or switch, whatever you would want to measure. And we have an orchestrator that is at the same time responsible for controlling the power measurement, but also configuring the router and sending traffic in the case we do want to have traffic. And the output of all this is a text file that compiles the power model that you can see on the right. I will discuss this in more detail a little bit further. So as I said, I'm not really here to talk about the draft itself, but more what I've learned in this process of working on this power benchmarking methodology. And there are good, bad, and ugly things about this. I will start with the good news, is that I do think that the benchmark, the definition of the problem, like how much traffic, how many ports, and so on, is not actually a really hard problem. I don't have time to get into the detail for why. I will rather spend the time on the problems, right? So the first problem is that making the benchmark practical is actually really hard. Why is it so? As I mentioned in the intro, the power model we are trying to derive is not that complicated. It's essentially the sum of 4 terms. So you have the base power, which is how much power your router draws when you just turn it on. Then you have a static power that comes per port that you activate. Then you have the dynamic part that as a function of the traffic, right? Okay, so that's the type of model we are trying to establish. Now, if you want to do this, you actually have quite a few experiments that you need to run to do this, right? So there's normally, I would have gone through those steps, but all animations went away. So bear with me while I try to explain this slide. So essentially, we have 5 stages of experiment that need to be done. First, we measure the base. Then you plug in the transceiver while leaving the ports off. Then you take the port up, but not the line up. Then you take the line up, and then eventually you send traffic. And the issue is that almost for all those tests, there are not only one setup that you need to consider, but multiple ones. For the load testing, you need to test multiple packet sizes and bandwidth volumes. But you can have also different transceiver types, like you will have a different effects on the total power if you use optical versus electrical transceiver or different type of optical transceivers, obviously. You need to differentiate between QSFP versus SFP ports on routers that have both. And of course, all of those can be configured at different speeds. And of course, you need to do multiple of each run in every scenario to have better confidence in the individual results. So at the end of the day, you end up with a lot of experiments that need to be run in order to derive the power model of one router. Okay, it can still be done. It can be automated to make it simpler. We actually have done that. But finding the proper configuration for each individual router is practically pretty painful. For those of you that have the chance to program and configure routers on an everyday basis, you know what I mean. Every single router, every single OS has its quirks. And although you know that it has to be possible to configure VLANs on that machine, that doesn't necessarily help you finding the right set of commands to do what you want. So that may sound like silly, but in order to scale the such of benchmarking effort, that is a practical hurdle that we faced. The second point is a bit more subtle, is that in this methodology, we make somewhat the implicit assumption that two, say, QSFP port on one router behave the same. And that happens to be not always true. Because on some router models, you may have different speed groups, different ports that behave differently, that can support different line rates, that support different service lines. And that has an effect on the total power that you have available. And it's pretty hard because the data sheet don't tell you this. And if you try to look after the measurement, it's pretty hard because the effects are small to see, but they are still there. I'm going to move quickly to the interesting part, I think the most interesting part. We can do this. We can automate. We can derive this model back, and we trust them. And I think in the room about benchmarking, that's not going to come as a surprise to you, but benchmarking is really at the end of the day about ranking options. Like, we need to be able to say, is A better than B, or is the new version of A better than the old version of A? And in the sense, we must have trust in the results. And this is where things get ugly, because I don't think we're anywhere close having something that is trustworthy at this stage. So let me give you, okay, the layout is really messed up here. Sorry for that. The three pieces of evidence of the type of things that change in ways that are somewhat surprising. So on this plot, what you can see is measurements that were collected for different power supplies of the exact same router model across a different network. And those blue dots you see can be anywhere between a very good power conversion efficiency above 95% to very bad, below 80%. So we have a 15% difference between the base case and the worst case, which means, like, for the same router that consumes about 200 watts, we're talking about a 30-watt difference, just because the power supplies are good or bad. And it's not clear at this point, like, where this comes from. We quickly check the temperature. That would be a likely suspect, but temperature doesn't seem to explain that conversion efficiency difference. So something else is at play, but we don't know what. But what it means for benchmarking is that if we take one number and we neglect that impact of the power supply themselves, then we may draw a wrong conclusion about this router model is better than this one, just because they use worse power supplies. Here's something else that changed. So here is a different graph with the total power draw of one router, the exact same one. And around mid-March, we ran a software update because something else was messy on the router, and boom, plus 50 watt. And it turned out that that happened to be just because the new version of the OS had a different temperature control policy, and the fan just started spinning like crazy. And it seems that somewhere in the summer, people at Cisco realized and shipped another version of the OS that reverted that change. So it seems that we also need to look and be careful about which version of the OS is being run when we assess a router. So it's not about only about the hardware, it's also about the software. And finally, third and last piece of evidence, here's the exact same router, exact same setup, same experiment. Just I run some experiments at night. Next morning, I woke up, I run another series of experiments, the exact same things. It looks different. I don't know. I have no idea what happened, but something happens, and it's pretty hard to get stable results when it comes to power, because there are so many confounding factors. Okay, so trust is a must, but I think we're not quite there yet. And so you may wonder, so what? Should we just give up and forget about benchmarking power? I think we can do some stuff. I think two action items I would see for maybe this working group. The first is that we must really make it easier to benchmark your own router.
Romain, just a warning, because in few minutes,
yes,
I think that Mitico will be shut down. So,
okay, I'm done. I'm almost done.
Yeah.
Less than 1 minute. So we worked hard on this automation tool chain. We'll publish it, but it's still a research prototype. It's quite brittle. If we would welcome contribution to make it better.
No, I would suggest, because we will be just shut down and we will finish improvising.
Yeah, it's my last slide.
Yeah, I just want to say no that I would suggest to update the draft on benchmarking for power usage of the network element. So this is for the next meeting. So this is something because you presented a lot of very good results and considerations, and that will be integrated in the draft.
Mm-hmm.
Please,
I also make it very quick. Carsten Rosenhöfer. Excellent work, Romain, and I think this is really needed. We've made similar observations at ENTC. I have some explanations, but we'll take them offline. So let's have some email discussion.
Yeah. Thank you, Carsten. Yeah. So, sorry, Romain, I interrupt you just because Mythico will be shut down. Will be shut down improvisely.
No
please.
Just to second that, this looks fascinating, and we should see more of it when you have time.
Yeah, I do hope to come to the IETF soonish to share a bit more in depth some of the things we found there.
Yeah, and please join the benchmarking working group mailing list, and so we can. Okay, so we can continue the discussion there about this draft and this work because Carsten is interested. So I'm interested. So I think that a lot of people is interested.
So until I'm cut off, just some closing word. So the other thing I think we should do is that to rather try to make one benchmark extremely precise and extremely prescriptive so that we can replicate the results. I think what we should rather do is to have more loosely defined benchmarks, but that are easy to run, and then aggregate many results. And then we can do a meta-analysis of the results to get a better confidence of the trend. For this type of router models, we run like the benchmark 25 times on 25 different machines. And here's where the result seems to be. I think this is a much more promising approach for benchmarking power.
Yeah, of course. We have already a baseline document, but that could be improved a lot with all this kind of information.
Definitely. Yeah. And since I'm not yet cut off, we try to put together a public database to aggregate every power-related information on routers and switches, network devices. And so the power models that we derive will end up there. And we are still trying to aggregate more type of power information. We've done a lot of work on datasheet parsing and scraping, but I don't have time to talk about it today. So yeah,
okay.
Thanks everyone.
Thank you very much. And let's continue the discussion on this draft. And
yeah.
So
Thanks.
Yeah, thank you, Romain.
Enjoy lunch, folks.
Yeah, thank you. I also want to close the meeting, so we're running a little bit late, but an interesting presentation in the end. Yeah, see you in Bangkok. Bye-bye.
Thank you. Bye.
Bye.